Do you feel like things are more expensive?
Yep.
Welcome back to the channel. My name is Chris Pulliam, and I am an analytical data scientist. And oftentimes I'm combining my analytical chemistry expertise with my data science toolkit to help me understand complex data. So now this is tax season. I've paid the government a lot of money very recently. And one of the perks of paying our taxes is access to our data. Now, this may not justify the full price, but this is a benefit that we can take advantage of. So on the website for Bureau of Labor Statistics, we can actually see the price of food, for instance, and a nice graphic that helps us to understand the overall economy and how food prices have changed over the past nearly 20 years from 2005 all the way to 2025. And this is a really cool figure because they've built some interactivity. We can see that we can track prices for various things like bananas per pound, bread, chicken, eggs, ground chuck, milk, and other items that might make up a cart, as well as some of these services like electricity, gasoline, and piped gas. And so I want to demonstrate how we could take this data and quickly make similar types of line plots from this in Python. And with some extra code, we can actually understand more of the monthly trends within this data set visually. And then in future videos, I'll dig further into this data set, both in my Python programming and using no-code solutions like Orange for data processing. Let's get started. So here is a very nice figure that I want to recreate in Python. So the first thing you should be thinking is, where can we find the data? If I look at this show table link here, we have a graphic of the data. So you can see we have the month and the year, and then all of the food prices that were represented graphically in this table here. And simply by scrolling down, we have access to this entire table. Now for this process, I simply copied this entire data table into an Excel file and use this for my own data processing. Now, I know there are ways that we can access and download this, but sometimes you just want to grab the table really quickly and begin your data analysis journey. And so I did just that. And in my public data folder, which is where I store this data, I have this Excel sheet where I've simply just copied that exact table. And you can see that this is what was represented in the last screen here. If you can go all the way down. And then I have an IPython notebook where I'm going to be doing my data processing. And so I will upload this into GitHub and you can follow along. You simply just have to put the data in a directory and then ensure that you update this path, that everything else should work the same. So let's begin. Of course, I'm going to import a couple different notebooks and I'm going to read in the data. The only input processing that I'm going to do is set the index column to column 0. And of course, I always forget to run this first cell. And here we have our data set where the month, which is what was denoted in the original table, is here. And then we have all of our categories: bananas, oranges, bread, gasoline, ground chuck, gas, etc. And so this is just a good way to using the head method to double check that we have the right data. And then I'm just going to fill the missing values with the mean value for each of those segments. And then in future studies, we can actually understand, is this the best approach? Maybe we want to do some different type of imputing to understand how we want to fit those missing values. But I want to start creating that figure we saw in the last page. And so let's start looking at the inflation and how everyday prices have shifted over time. If I open this section there, you can see first thing I want to do is melt the data frame. And I'm going to do that by first resetting the index. I'm going to reset my month index. And they're going to set my new ID vars to month, var name to food, and value name to price. When we run that, let me show you the first 5 rows of data. You see we have our month, our food, and our prices. If I sample so that you can see a random subset, in this case, 5 random rows, you can see we have various months. We have our food price, we have our food categories, and then we have that price. And this is the data we want to start collecting. The reason I'm melting is that I'll have more control over the figure if I can set my hue values to the food category versus relying on the original wide data set here. And so melt is a critical function for data processing, enhancing your data viz abilities, and it can be really simple in combination with other tools to do this as well. So what I want to do is create a line plot using meltdf, where X would be the month, this column here, Y would be the price, this column there, and then I want to color by food. And that is why I melted this data frame. And then I want to add a legend using the plg.legend, set that to food category, And using this B box to anchor, we'll just assign the location of our legend based on a root position in the upper left corner, and then using the dspine method to help me make this plot a little bit less crowded. Now, this is a really good start. We have a plot that's really similar to the original figure. Let me show you what that looks like again, where we have a lot of the information that's here in the original plot. However, there's a couple things that I want to consider. One is the interactivity. We have the ability to understand what's going on. We also have the ability to refilter the data. So as you can see, the banana line is really flat when you consider all the other lines. And so one thing we can do is remove all the other data. You can see how it begins to rescale and make this banana seem a little bit more significant. We can understand those changes more. Now, there's a couple different ways we can address this in the source data, but visually it's nice to be able to filter down to just a couple different categories and understand how those things have changed in the context of everything else. So let's now build some of the interactivity using Python. Now, this figure was created using the Seaborn library. However, you can create advanced figures using Plotly Express, which has more of this interactivity natively built into the library. And so I want to take my same melt df. I'm going to assign X to month, Y to price. In this case, instead of hue, we're going to call it color. To food, title will be food prices over time. Template will be Plotly white. And by running this, we would get really close to that original figure, where now if I want to just see my banana data, I can just double click the banana in the legend. If I want to see everything, I would double click it again. If I want to remove it, I just single click, and you can see how we're already beginning to get our y-axis rescaled, and we can see the same kind of interactivity that we saw on the BLS website simply by switching from a Seaborn and Matplotlib figure to a Plotly Express figure with largely the same parameters. And so this is one of the benefits of understanding multiple different plotting libraries. Yes, you can build some interactivity into Seaborn and Matplotlib, but it works way better, more natively in the Plotly Express ecosystem. And so let's enhance this even more. If we look at this figure, you notice they have a bounding box that allows them to understand some key events. In this case, this gray box here is from the 2008 financial crisis, where we had our Great Recession. And then this sliver here, I'm sure is tied to COVID-19. I would probably broaden that out in my figure, but this kind of gives us an idea of why some of the food prices may be changing, whether that's up or down, or we just might call that volatility because of these global events. So let's add that to our figure and further enhance our ability to understand this data set. So let's go to our advanced line plot, and I will show you how we get from this figure here to something with more features added to the plot. So this line here is virtually the same. I've just updated the title so you can see this is with the highlights. And then I'm going to add a shape using the fig.add_shape. And one thing to notice here, I didn't assign this to a variable name because I'm just making a quick plot. Whereas in this cell here, I do now assign this px.line to this figure variable, this fig, so that I can then update it and add new layers to that. So what I want to do is create this line plot and then add a shape to it. And in this case, we want to add a rectangle from December 2007 to June 2009. And this will correspond to the Great Recession. And then I'm going to fill that box with red, and you will see this now. And by adding this, we're adding more context to what could have been happening during that time. And now I want to add another rectangle for the COVID-19 pandemic. And so when we add that, it's really nice. We see those boxes, but our lines are still really clear. The challenge is, however, we have not annotated these boxes. So if you are from somewhere else, or you don't have this context based on the history, you might not know what those represent. And so we can add annotations simply by using the fig.add annotations, and I will add these at the same time. And let me make sure I comment all the lines. When we do this, you see we now have annotated the Great Recession and the COVID-19 pandemic very simply, still using the Plotly Express library. We still maintain a lot of the interactivity So I can remove everything still. And then lastly, I just want to move my legend down to the bottom so that I can take advantage of the full width of the screen for rendering this figure. And when we do that, you see we have now just stretched out our line plot even more. If you want to adjust the X and Y location of that, you can just use the X and Y, and this will actually adjust the location of the legend. So in this case, if I want to slide it further down, instead of the negative 0.7, I'm going to set it to negative 0.9. And you would notice that it just slides further down, creating more space between this X axis and the legend. And there's, of course, way more customization, but this is a great start for using Python to recreate those figures, especially if you like them and you want to sort of use that as a goal, a way to practice clear data visualization. So let's continue understanding this data. And instead of looking at the longer 20-year period, let's look at some of the monthly volatility and address that through some data cleaning and then a heat map for data visualization. So the first thing I want to do is Z-scale the data, and it may not be that clear. So let me show you why really quickly using another figure. If I look at DF, again, this is the data frame we've been looking at. We have our different foods and each month for the past 20 years. And I plot histogram. Let's just say plt.tight layout to kind of give ourselves the best chance of rendering everything somewhat clearly. Here, despite the titles overlapping, you can still see that the spread of these variables is really different. So let me set the shared X equal to true so that you can see right now, in this case, the X axes are very different, and I can kind of mask the shifting that's occurring. And when we do that, you can see that in some cases, like the banana, the values are really small. In other cases, like the ground chuck, the values tend to be a little bit larger, and we have a lot of differences in our means throughout this process. So one way we can get around this is by subtracting the mean value from this data frame. If we do that and say df.df mean and subtract that, you can see we can mean center the data. So now all of these values means are near 0. You can see here, they're all around 0. Same here and same here. And this greatly improves our ability to compare the volatility of these different data. We can also z-score the data, and that's simply by dividing by the standard deviation. And this will further make our analysis robust if we're focusing on just how much are these parameters changing or when they're changing. Now, there's cases where you want to use it and where you don't. And this is where the domain expertise really comes in. In the case for me, I actually want to take advantage of that for my data visualization because it'll make my figure way more clear and you can see where those fluctuations are occurring within the data set. And so because of that, I'm going to mean center the data. I'm going to divide by the standard deviation. I'm going to do a transpose simply to help enhance my figure, and then save that as z_df. So this is z scaling there. And then in this line, I'm just formatting my date time, which I'm establishing using the pd.datetime. And this just, again, helps clean up the heat map figure, which makes different assumptions about what those timestamps mean. And so I'm saving that as z_df. You can see what that looks like here. If I just preview the first 5 rows again, run the cell, looks largely the same, but now these values are z-scaled. And so each value, if we look at the mean, will be around 0. And so this is due to limitations of our compute. The values won't actually show 0, but you can see that these are really, 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 really small values. If you look at the standard deviation, they're going to be all unit standard deviation because we're dividing by standard deviation here. And so this is, again, a great way for enhancing our visualization and perhaps even improving some of the models we may build based off of this analysis. And then I'm going to use a heat map from Seaborn from my z_df. I'm going to use the Viridis color map. It's just a very pleasing color map there. I don't want lines because my heat map will already be really dense, but if you want to, you can add some contrast using lines and maybe play with the color there. And then I want to make sure that my X ticks are at a 45-degree angle to ensure their readability. And then I'm going to set the title X label, Y label again, a tight layout, and plt.show to render this figure. And now with this figure rendered, you can see where we have some of our volatility, and it definitely changes over the period of time. You can see that here eggs have really spiked towards the late 2024, early 2025. Again, we know that there was avian flu. We see there's quite a bit of periodicity in the orange cycle here. This could be to natural changes in the season where oranges go in and out of favor over the time. We see that things like the gas kind of has a fairly stable increase or decrease over time. Same with meat and really everything in between. Tomatoes also have some sort of apparent seasonality. Same with electricity. And this could be due to baseline costs plus some of the weather changes and everything else. So this is a really great way to understand this data. And we started all by trying to recreate this figure here, but because we have access to the source data, we could do a whole lot. So I challenge you, if there's data you want to understand, go and find it, particularly if it's about us, right? About us as humans, us as US citizens, or wherever your home country is. You can even find data for various major cities, and every state has their own open access public data if you want to study that and build up projects there. If you enjoyed the video, like, comment, subscribe, and I'll see you in the next one. Peace. Oh wait, I should say, I will be doing a low code version of this as well using Orange software. So if you want to check out the video, like, comment, subscribe, and I'll see you in the next one. Peace.